Today we are graphing polynomials by hand. Last night we learned how to find all these other things that are going to help us. So the first thing it asks us is, what are the maximum number of turns this graph could make? 2. And that number comes from, just to refresh our memory? It's 1 less than your degree of the whole thing. So if the whole thing is third degree, the number of turns that it could make is 2. Number 2, determine the real zeros and state the multiplicity of any repeated zeros. Okay, so I basically have to solve this polynomial. What would you do first?
Take out an x squared.
I would. In fact, if you don't mind, I'd take out a negative x squared because I can't stand when that leading coefficient is negative. So now that's a positive x, and that's going to be a minus 2. How many zeros will there be altogether? 3 altogether, right? Because it's the same as the degree. I have all of them now. I know what they all are.
0 multiplicity of 2.
Right, I get 0 twice from that. So I get 0 with multiplicity of 2. And then I also get positive 2. And I just get that one time. So I should have 3 answers. I do. 1, 2, 3. Now, in line 3, they're asking me, okay, which of these are going to cross and which are going to bounce off the x-axis? Will anybody bounce? Who? Yes, we're going to bounce at 0. And how do you know when it bounces or when it doesn't? Exactly. If you have an even multiplicity, it's going to bounce off the x-axis. So in other words, it's just going to touch the x-axis at that point. It's not going to cross through. Okay, so I'm going to bounce at 0 and I'll pass through at 2. So we'll see how that looks on the graph in a minute. 4 is describe the end behavior. So as x approaches negative infinity, that's if you do it with your hands, that's what's going on with your left hand. So given this scenario, if your leading coefficient is negative and your degree is odd, what's your left hand going to do? Goes up. Right. And then, as your x approaches positive infinity, that's your right hand. What's your right hand going to do? Oh, yeah, sorry. It goes down. So, odd exponents, they do the opposite of each other. And since the leading coefficient is negative, you're going to start. It's going to come from the positive. Good morning, Miss Sabia. Oh, hi. Yes. She saw Carrie. Yeah. Yes, and I told her that you had called, and she said that she'll stay here. If that's all right. Or do you need her? Or? Oh. Me too. Do you want me to ask her? Or are you being dismissed or are you staying? Right now or later? Okay. All right. She will be getting dismissed soon, but she's here with me now. Okay. Yes, we have lunch at 26, so I don't. Do you want her to stop in and see you at all, or? Okay. 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 No problem. Bye. Miss Finn wants to see you. Sorry. Yeah. I don't know. I don't know if you're leaving soon, if you want to take your stuff, or I don't know. I'm sorry. Whatever you want to do. Okay. So, where were we? Oh, yeah, we were talking about the end behavior. All right, so here's where we're going to start. We're going to start the graph with the zeros that we have, okay? So I know this thing is, I have zeros at 0 and at 2. So that means at 0 and at 2, that's happening, right? Now, because it's going to bounce at 0, right? It's going to bounce at 0. Now, I don't have any zeros over here. So what that tells me, since the left-hand side is going up to infinity, that means that this is just going up.
How do you know, like, how, oh, it's up? Yeah.
Up like a cup.
Well, because shouldn't it be wider because it's the thing is -1? Does that not matter? I guess negative x to the third. Is that not the slope?
No.
Or is it?
Yeah, it really, that just tells you if, so the sign of the leading coefficient is just telling you if you're going to be going this way or this way. It doesn't really have anything to do with,
So does, like, how wide you make it not really matter?
no, yeah, so you're saying, like, could I go like this?
Yeah.
So here's the other thing. We're graphing by hand. We're not being super specific. If this, as long as this is going up forever, it's okay. So I don't really care where you put it, as long as it's clear that you're going up there. Now, I know it's going to bounce off of 0, so it's not going to cross down here. It's going to bounce back up. I have no idea what is going to happen at 1. It could go super high. It could be kind of low. All I know is that it's not going to be negative, right? Because the next time I hit the x-axis, it's at 2. So what I should do is I should plug 1 in and just see how high it goes. Okay, so if I plug in 1, that's pretty easy to do. I mean, I don't have to do synthetic substitution. I can do that in my head. So if I plug in 1, that's going to be careful though. 1 cubed is 1, take the opposite. So that's -1 plus 2, +1. So there's another point on my graph is 1, 1. So I can pretty confidently make this assumption that it's going to do this. That may not always be true, because remember, once you leave quadratics, we're not symmetric anymore. Anything could happen. If I plugged in 1.5, it could shoot way up and then come back down. I have no idea what's going on. I don't expect you. How could I expect you to plug in every number between 1 and 2? I don't. You couldn't. You'd be here forever, right? So I'm only going to expect you to plug in integers, your whole numbers and the negatives. If something weird happens at 1.5, whatever. Well, it's not that we don't care. It's just that when you're graphing by hand, there's certain limitations. You can't graph every, you can't, it'd be crazy. Now, at 2, I know it's passing through, and I know I don't have any more zeros, and I know that the right-hand side is just going down to -infinity. So that's pretty much what we're going to do. We're going to start with our zeros. We're going to plot them. The end behavior just helps us figure out what's going on the ends, and then to kind of flesh out the middle, we might have to plug in a couple points and just see what's going on. Does that make sense? Okay, so let's try, I want to do one that's maybe a little bit harder, but not so crazy yet. How about, no, that one doesn't look good either. Wow, maybe I gave you a lot of toughies. How about 10's looking pretty good to me, 10. Okay, so, oh, and one thing, how many times did we say this thing could turn? We said twice, and look, it does. Once, twice. Maximum number of times it could turn, so it can't have any more turns than what you said. So, how many times, maximum number of times this thing could turn? 3. Now I have to find the zeros. Okay, first thing I'm going to do is take out a -1, because I can't stand it. So, x to the 4th minus 2x squared plus 1. How can I go from here? Any thoughts? I can use a quadratic pattern because I had to the 4th, to the 2nd, and then none. So, I'm going to factor it like normal. Factors of 1 that add to be -2 are -1 and -1, but what's the change that I have to make? They're both squareds, right? which means that that's the difference of two perfect squares, which means they both split into x plus 1, x minus 1. What happens with this -1 out here? It's gone, because remember, you're setting the whole thing equal to 0, so you could just divide both sides by -1, and you don't have to worry about it anymore. How many answers should I have? 4, and I've got them. I have -1 twice, and I have +1 twice. So x equals 1 with a multiplicity of 2, and -1 with a multiplicity of 2. So, what does that mean? At 1, what am I doing? I'm going to bounce. And at -1, what am I doing? Yes, 1 and -1. So both of them are going to bounce off the x-axis. So do I ever actually cross the x-axis? No, because those are all my x-intercepts. And at both of them I'm bouncing. What is the end behavior? Yes, they're both down. So listen, I'm going to let you be lazy and just draw them as long as you would know how to write it fancy on a test or a quiz. But if while you're sketching you just want to draw the arrows, that's fine. Okay, so I know that both ends are going down to -infinity. And I know that I'm going to hit the x-axis at 1, and I'm going to hit the x-axis at -1. So what does that tell me? That tells me you go like this and you go like this. So it's just what's happening in the middle that I kind of need to flesh out. So lucky us, there's only one number to plug in. What is it? Yeah, 0, right? Because I know what's happening all here and all here. I don't know what's happening at 0. So let's plug in 0 and what comes out? -1. And that makes sense because I knew that both of these were going to bounce. So it looks like that. Yeah. No, yeah, sorry. Is it dark enough? Is that okay? Does that make sense? Everybody's all right? So, unfortunately, not all of these are so easy. Some are a little bit tougher, like, let's pick a hard one now. How about, you want to do 1? Let's do 1. 1's tougher. And it's only tougher because it's more of a pain to find the zeros, that's all. So, number 1. How many times can this thing turn around? 3 times. Now I have to find those zeros. It's annoying because I don't have, what am I saying? I can't factor by grouping. There's not a common factor I can take out of the whole thing. I'm going to have to do the synthetic division. But lucky me, the factors, there's not that many. Positive -1 or positive -2, right? That's it. So, shouldn't be too bad. So, let's see. -1, 1, 3, -1, -2. Make sure you watch out for 0 placeholders if you need any, but I don't think we do. And let's just plug in until we get a 0. Hooray! I have one of my answers. Now, this crazy thing, so that's my remainder, constant x to the first, x squared, x to the third. I'm still not down to a quadratic, and I still don't, I don't think I can factor this by grouping either. So I'm just going to keep going. I'm going to keep doing, I'm going to check if 1 works again. So -1, -1, -1, 2, 2. Nope. Let's try -1. So now that's a +1, a +1, a -1, +2, a -2, a 0. Hey! Hooray! So I have two of my answers so far. One works, -1 works, and now I have this quadratic that's left. -x squared plus x plus 2. I can't stand that my leading coefficient's negative, so I'll divide everybody by -1. And now I can factor this. X minus 2, x plus 1. So I have all my zeros. Do you see them all? I got 1. I got -1 2 times. So -1 with multiplicity of 2. And I also got a positive 2. Am I going too fast? All right. All right. I should have 4 answers. I do. I got 1, -1 2 times, and I got 2. So now I know I'm going to bounce at -1, and I will pass at 1 and 2. And my end behavior, both down, correct. All right, so let's put all these pieces together and let's figure out what the heck is happening. So I have zeros at 1, -1, and 2. 1, -1, and at 2. I know my end behavior, they're both going down. So from here I can go down, and from here I can go down. I just want to flesh out what's happening in the middle. So let's see. At -1, I'm going to bounce, which means that I'm not going to come up here. I'm going to bounce. I don't know how low I'm going to go, but it's going to bounce right here. So what should I do here? Plug in 0. Plugging in 0 is usually really easy, right? Just pop it in, what comes out? -2. So that's going to bounce off that x-axis, and it's now going to hit at -2. Now, look, at 1, I already know where I'm going. I'm going right here, so I'm going to go right there. I know it passes through. So, in other words, it's going to pass through and come back down. Here's what I don't know. I don't know if this is going to be a teeny tiny little hump, if it's going to be a big hump. I don't really know. So, I would love it if you plug in 1.5, just to see how high do I go. But remember, you have a calculator at your disposal. So if I just use a calculator and I plug in -0.5, let's see what happens. 1.5. 1.5 to the 4th plus 1.5 to the 3rd plus 3 times 1.5 squared minus 1.5 minus 2. Spits out a 1.5625. So it goes to about 1.5. So now I know how tall that little hump goes. Otherwise, I just wouldn't know. I don't know. Without plugging in something in between, how do you know how high you're going? But hooray! That's it.
How many things we're gonna have to do for homework?
Oh, I don't know. Loads? This will be more fun than that.